Yeah, so hello everyone. We will have a session on source extractor. Some people have been having issues installing it and running it. And this today we'll look at it, how we can do it in Linux. Okay. And it's quite simple to install. One thing, like I had mentioned, you can search for help on net and you can uh, work out your issues and problems. I will Linux machine and show you how it's done. Okay, so this screen which I'm sharing right now, this is of Linux Mint. Linux Mint is essentially, it has the same kernel, Debian kernel like Ubuntu has. So it's exactly the same. It's slightly a lighter version. So since my system is an old one, I've installed Linux Mint on this, and I also have Ubuntu running on another partition, and the function and the way they function is essentially the same. So one way of doing it, the simplest way of doing it is you open a terminal and you run this command sudo apt get install, and then there are either you can call it SExtractor, source extractor, right? TOR, right? Or sudo apt-get source dash extractor. So if you say sudo apt-get install source extractor, sudo is for your to give the administrative privileges to your system. You'll have to give your password, and then it starts installing. Like all of you who have been using Ubuntu or Debian or any version of Debian, this is how we install a lot of software. So here you will see that it says the source extractor is already the newest version. So 2.25 this thing, right? So it, since it's the newest version, zero upgrade, zero newly installed, right? So if you want to uninstall and reinstall, then we'll have to, right? So I will, if it is not installed in our system, then it will start installing. Okay. So this is one way of doing it. Similarly, you can, there's another, if this is not working out for you, you can do a sudo apt-get install -c, sorry, yeah, not sudo, but conda install. Conda install -c conda forge -c astro drama, and you say source extractor, or yeah, source extractor. Okay. So this will also do the installation, and it may take a long time to install. Okay, so I will can send the command. I'm interrupting it, but this would install. Another way of doing it is you can click, like in Windows, the Linux has the button sitting right below. If you click that, this opens up something similar to what a Windows in how it does in Windows, and there is this package manager. So if you press the package manager and give your root password or the super, you give the authentication. From here also you can search and install the software, right? So here I have a search button and I search for say source extractor and I search and it is showing me that this is already installed source extractor installed version 2.25.0 DS2 and the latest version is also the same one, right? And it's giving a short description below. It says it finds sources such as stars and galaxies in astronomical images and so on. The input files are in FITS format and all that. So this is telling us that yes, we are looking at the right thing. This was extractor for astronomy images. And since it's already installed, there is nothing to do. If it wasn't there, then we could have clicked this button, apply. The apply button would have been activated. And when we say apply, it would have installed it. Okay. Now, what is happening is when we are looking at various manuals, there are many different sources of distribution. This source extractor, GitHub has this distribution on various pages of people who use. They are providing it, and there are all kinds of manuals which are also available. And this is probably creating some kind of confusion with you because those manuals say that you have to run the command source extractor and the file name and you give your whatever file. So I will go into a location where I'll get into a directory where I have kept some files and this today is what, October 24th. Yeah, so I have too many uh, similar sounding, similar looking directories. So I have a FITS file here, test image.fits. And if you are reading a manual which if you would say this SEX and you give the file name of your FITS file where of your image. Yeah. So if I say this and I say test, obviously it is what I'm trying to show is it's going to give me an error message, nothing will work, right? And it says it hasn't found this command sex. Okay. In some manuals it will say run the command SExtractor, yeah, source extractor and give the file name test image.fits, and again it is not finding it, right? And there in some manuals it will say you run the command source extractor and the file name, yeah. And in this case when I run it, it has run, right? And it is showing me it has detected 508 objects and has identified the sources as 476. Okay, with certain parameters. It is saying that root mean square velocity is this, the background is so and so, the threshold is so and so. So if you change the threshold and other things, then you will find lesser or more objects. We'll get into that a little later. But now it's running. Okay. Now the question is, what is installed on your system, and how do you know which of the three or how you have to run? Okay. So in fact, even we had trouble doing it. So what you have to do is get into your directory USR in root, and there is a directory called share /USR share. And here you have various things which have been installed. Okay. And you will see these are all the things which are installed here. And in this is the location where this source extractor has been installed, right? And this is a directory. So if I further get into this CD and I do source extractor, I see that this is where my all these files are there. Okay. So this has, as you are noticing, various files, and there is a README file. In this case, there's nothing much to read in this README, but often you get into these README files and read them. Okay. And you will see that it has Gauss underscore 3 point this called when met hat and top hat, and don't get into all this as of now. Important things you should look at is this default conf and default NN neural network NNW, default parameters, default sex. These are the essential, at least most essential things which you require, right? So copy them instead of making changes here and running it. You can copy them and get it into your work directory. So create some work directory in whichever location you have, and you dump them into it. For example, I created a work directory on my desktop, and I have dumped these files here. Okay, and we are going to run it from here. So that these things were not there. These things were done after we ran it. Okay, so basically we have these files. Default, if you open the default file, you will show you what are the catalog name. Is test.cat. It's the name of the output catalog. So when you run it and it creates a catalog of the sources, it is going to write it here. So obviously you can change this to whatever you like. You can call it my first run, my test, right? So I have called it test.cat. Okay. Catalog type is ASCII head. Yeah, so it can be ASCII head with header, ASCII file. It can be a FITS file. It can be a FITS LDAC file. So there are different options. Here, the option is say ASCII underscore head. Yeah. So it will come with a header and it will give you in ASCII format. Then the parameter names. What are the parameters which you want to pull out? And you have the DAO find.param file. This is in this case, I will rename it to say my default.param and run, right? And In the default param, I'm going to put all the parameters which are required. Then we have the detection type and image this and all these things. Again, important thing which you see, as you proceed ahead, you will learn how to control these things, how to change these parameters, and how do you get these parameters. And obviously, some of you who have been with us for a while, they know that header information of the image fits file has information which has to be fed here. As of now, you don't bother much. You want to get it going. Yeah, so again, filter name, you want default.conf. This file has to be there in your location when you are running it. Otherwise, you create problems and so on. Magnitude, 0 point, magnitude, all these things are there. What is the seeing FWHM, right? These are in arc seconds or what. Everything is, there's a comment on the right hand side and it tells you what all these things are. Okay. So this default.sex, it is giving you this information. Now let me open the close with saving or without. Look at the default parameters. Yeah. Before I get into this default parameters which I have, I'll show you what we had it in a user uh, uh, in the USR slash share source extractor. There was one default parameter file. So let me open that. If you don't have this parameter file from where you are running, it will go and get it from that location. And you notice this default parameter file, which is there, which is sitting in your, when you are installing it. It has all these things, exactly what you have seen it in this default.sex. Let me open into different windows so that we can see what these two files are. And it says, a catalog name. So here you see if you have your number, the running object number will appear. At the moment, if you notice, all of these are commented. And that's why when you are running it, you are getting some error. You have to pull out something or the other. Okay. Otherwise, yeah. So what we have done is we have made a very simple default parameter file. Not here. Where is my session? Yeah. So my default parameter file. Oh, no, this is not my source session here. Yeah. So we are running it from here. Default. I have called it test parameter file, and I am just pulling out X image, X coordinate of image, Y coordinate of image, and magnitude best. Okay, just three things. Okay. Yeah, so there are many things. If you, one way of running it is, which will get you into trouble is, if you go into your main default parameter file, which you have here, and you say find and replace, edit. If you say remove all these hash, yeah, it will remove all of them. And when you run, you will get hundreds of parameters columns there, and it will stuff up your system. So right now, we are doing it with something very basic. We need the location, the source location and magnitudes. Okay. And then we have this default convolution file and default NNW file and all these things here. And when we ran it, yeah, I showed you, I ran that file and we found that there were so many objects and there were so many sources, 476. And it has created which file? It has created test.cat because in our this default.SEx thing, we have written that it should create a test.cat, right? So this test.cat file was not there and it has created this one. And see, we had looked only for X coordinate of the image, Y coordinate of the image, and the magnitude, right? Best of magnitude, auto, and between these two, in the main file which you have these two, and we have pulled out only 3 columns. Okay. So you first try doing that, pull out only a few columns which are essential. So I thought most important is your location. Yeah, that is the most important, and also the magnitudes. Okay. So it has created a catalog. Now we will open this image and we will load these sources. We'll mark it on the image. And how should we do that? Earlier we have done this in Galfit, but in the previous sessions, not with this group. And one way is you can use DS9, yeah, DS9, which opens the image, or you have SkyCat, DS9, and I will open that image which we have, which was this test image.fits, and this is our thing, and we can take different scales to see what it is. We will zoom it to fit in the window. Okay, so this is what it is. Okay, now to be able to plot these sources which the source extractor has done. Earlier what we did, we took these sources from catalog from a site. We were using coma cluster object and we had found a place where the sources had been extracted and the catalogs were available there. Okay, exactly the same way, but now we'll do it with what we have done here. Okay, so this catalog which we have created, it is in ASCII, right? It's an ASCII thing. So we'll have a problem with DS9 to read this here. So what we do is we will I'll start this stopcat. We had done the same thing if you recall earlier. Somehow the system is a bit slow. So so it has opened this stopcat and you open the file. It asks for the location and you go to the desk wherever your file is. And I have to choose the table format. And this time it is an ASCII format. It could have been comma separated, whatever. So you have to change the table format. And this was the cat.test. Okay. So, yeah. So as you notice here, you have that catalog opened up in it has opened in our Topcat. Okay. So it has these three columns, 1, 2, and 3. One is your X coordinate of the image. Y is this one. Y coordinate is column 2, and the other magnitudes. Okay. So now I will save this file, save this table in the VO format, the VO tables format. Okay. So output format, I will choose. There are all these possible formats, and I will take VO tables data. And where do I save? I'll save it in my working directory, and I'll call it, say, test.vot. Okay. And the output format is VO table. So it has been saved in our location. Okay. So for the moment, we don't need Topcat. It's done the job which is required. Now coming back to the DS9, click this analysis, and you have catalog tools, right? You have catalogs. Either you can take catalogs from net, from some databases, from Simbad, all these, but we are going to use the catalog which we have constructed. So you go to that, and then file, and we will say load. Okay. Just a moment, it will give us a small error. Okay, I'll do it. Load, and I will say this test.what, right? And I'll say okay. And it is not showing up here because, it has shown here, but it is saying bad coordinate mapping, unable to create some regions. And the reason is this, that if you inspect the image and inspect that file, you will see that the coordinates are not matching with the file. These are world coordinate. This catalog tool is expecting to find world coordinate. You see here, X coordinate is column 1, Y coordinate is column 2, and the third is world coordinates, WSC. But actually what we are using is not WSC, right? We are not using that. These are image coordinates. So the moment I chose that, you saw that all those images, they have been marked by green circles, right? So one way of having done this without getting that error and then doing it is would have been, I'll clear this now. I'll redo the same thing, and I say catalog tools, and right away, since I know this is going to create trouble, I go to image, and then I will, this time it will do seamlessly. So I say file, test dot, and here it is. Okay, so it has found those sources and it has matched them up. You can see that. Okay. Now the problem is there are a bit too many of these. Yeah, there are too many here. And what we want to look at, say, only the brightest ones, the brightest 16 sources, brightest 5 sources, or so on and so forth. So what can we do? We go back to this Topcat, and you make a subset. Yeah, in Topcat you have this thing, the purple ellipse with it is showing a subset of that. And you say create a new one. You give some name, say bright, and you can give an expression if you write. So you say column 3 should be less than, yeah. So before doing that, what I would advise you is look at the statistics of the whole data which you have here. So it shows you column 1, column 2, column 3. It is giving the mean of each one. It is giving the standard deviation of each one. It is telling you the minimum and the maximum of all. Okay, and number of things. Therefore, each row has an entry each. Okay, so we are going to filter using this column 3, and you look at this. Minimum is minus 14.48 and maximum is minus 5.71, right? It's a very big range. So we want to construct a subset. Yeah, so this is giving 400 and odd, 476 objects. 476 objects, right? So we can say, okay, from minus 14 to 0.48 to minus 10 or minus 12. Yeah, you can use a threshold and you can do that. So now I'll do it, right? So I'll call this bright test or bright, and you say column 3 should be less than minus say 10. Okay, if I say. So it has created another one here, which is 11% fraction. Yeah. So it has found 53 here, 53 now, right? Even if 53 are too many for you, you can make another one, bright test, and we'll take an expression column 3, which is less than minus say 12. And we are getting only 3%. Yeah, there are 16 sources here, right? So now, depending on what we are interested in, we will work this. And here I'll take this brightest and I'll go to save table. Yeah, so you have to select that which one which you want, save table, and again the table, it's remembering that we wanted VO tables, data table style, and we are saving it here. This time we'll call it bright test. Okay, we have done brightest and we have done away with the work here, and now we will work here. So catalogs, I'll clear this one, and now I will go back to this catalog tools. I'll change this to again image coordinates, and I'll take load which table, which is brightest. So now you will see that the brightest ones, you can see small green circles which are sitting inside these. So there are only 16 of these. Okay. So that's what it is. But obviously this is just the beginning. To see if you can run this and see you can do this, and then you should be able to set the parameters and things well in your parameter file, and then it will search out objects with the kind of PSF you want it to be, whether you are hunting out stars, whether you are hunting out galaxies in that, and so on, right? And here we have hunted out objects which were brighter than a certain magnitude. right? So, okay, this is the source extractor. And what I would say, advise is, try it with these images. Try download any fits image from the net, and you try to run with them. But yeah, yeah, and then in your computer, in your laptop, in Linux system, go to your slash usr/share, and here you have, find out what your source extractor directory is. So it is a source extractor one, and hence you will have to run this source extractor to run it. Okay, and if you take this default parameter file, the whole thing is commented. Everything is commented. That's why your output file, your catalog file is not being created, or it's totally empty, right? So if you run it with, yeah, so for example, I can go and rerun it. Um, yeah. So suppose I go into my location and I change this parameter file, this default.param. Oh, sorry, it was sorry, vi test.param, test.param, and I suppose I remove this thing, right? And I run this thing. Now, if I run source extractor with this on the same image, test image.fits, and obviously the threshold, everything is the same. But now when you see this test.cat file, it will have only 2 columns. Yeah. So basically, this is where you set how many columns you want to take, right? And this is a bad idea. Just taking these two will not. Yeah, it will. Then you'll not be able to sort it out further in terms of magnitude and so on. If you just need sources, the locations, these locations are most essential, right? So you can even siphon out much more information because header files have so much more information, and then you can exactly look at those objects which you are interested in. Okay, so with this, if there are any, yeah. So I hope it was clear, and I hope you try it and see whether you are having any problems. Okay, was it clear? Are there any questions?
So it was very clear. I think I will try and see if it is working now.
Yeah, okay. Yeah, so just try, and if you are having any problems, then write in Telegram, send those images of the errors which you are getting. And more than asking you and me, you better, you can also put it on the web page, this is the error I'm getting in this, and somebody will respond. We can respond, or there's a bigger community out there which is doing it in a very sophisticated way to do it, right? Vivek has some